So for Lab 9, we are going to use the VNA and the 4 calibrations and our stylus. The second cable you can simply put aside because we're not going to use that for the lab. We'll show you later on how you use the second cable for testing. The first thing you want to do is attach your cable to channel 0. And if you look here, you can see that the signal is going to go out of this channel, and that's by these 2 directional arrows, letting you know it goes out this channel and into this channel. Now what we want to do first, before we calibrate, is if we click anywhere, we can have the menu come up. And we want to go into stimulus, and I'm going to pick my start frequency, and I'm going to pick 500 megahertz. And now I'm going to go back to my menu, and I'm going to enter stop, and I'm going to do 1.5 gigahertz. And now I'm running from, it looks like 50 kilohertz to 1.5. I didn't get it typed in correctly, so my start is 500. There we are, 500 megahertz to 1500 megahertz. You always set your frequency first because your calibration is dependent upon the frequency. Next, we're going to calibrate the device. Touch anywhere on the screen, hit back, and then we're going to go to cal. We'd like to reset everything. And you should do this every time you use the device because you may have changed some setting and you want the calibration to be reflective of your current settings. All right, so I'm going to go back again, cal. Let me just hit reset one more time. There we go. And now I'm going to go to calibrate. You can see we have open, short, load, isolate, through, and done. We're not going to do isolation. We're just going to do open, short, load, and through. And what you'll do is you'll go through and attach the connector for each one of these and click it when you do. So here we'll zoom out. And our first one is an open. So I'll take the one that has no pin inside. And you can see I can't connect it to the cable directly. So what I'll do is I'll connect the adapter. And then I will connect the open, and then I will simply click the open button and it will calibrate the open. And now what I will do is the next one is a short. So simply remove the open. I take the other metallic one with the pin, attach it to one end. Once again, we should always try to screw from the left so the pin and the hole do not rotate. And then we go on and we'll hit short. Now we'll go and attach the load. We'll hit load. We're going to skip isolation. So now we're going to do through. Now, for a real test, meaning if we wanted to test a device, I would connect the second cable up to here, and I would do a through, and then my VNA would be calibrated to the 2 ends of these cables, and I could take that and put a device between these 2. In our lab, however, this cable is our device. So I'm going to set it aside again, and for just the lab, I'm going to connect my cable directly to here. And what this is going to do is it's going to remove all of the information or the phase delay and attenuation of this cable in our measurements. So I'll hit through. And now I hit done. And then I'll go back. Let's go ahead and look at the menu a little bit. So let's go back. Let's go to display. And so we just did stimulus. We could add markers. We could also go to our display here, and we could go to our trace, and you can see we have different colors. We could also go to our channel, and then we can also look at our scale. So I have my cable still attached from when I did my calibration, and what you can do is you can go to display, and you can go to channel, display, trace, and there's 4 traces. The way you know what the trace is, it'll say up here channel 0, which is this channel 0. And it means S11. How do we know that? Because the only thing that's measured on CH0 is S11. The only thing measured on channel 1 is S21. So it says CH0, so I know it's measuring the reflection S11. And now that I know I'm measuring S11, I can go to the format and I can click Smith, and that's what I get right here. And on yours, particularly when you put it in the computer, you'll be able to see the Smith chart around. But what you'll notice is that because I'm connected, it should be impedance matched because I've calibrated everything out, so I should be right in the center at 50 ohms. Let's go ahead and attach our 50 ohm load to this cable to make sure it also looks the same. There you go. I've now attached my 50 ohm load using the adapter to the end of the cable. If I now look, my measurement is still at the center, which tells me that I am indeed calibrated, and if I connect this cable to 50 ohms, it'll show up in the Smith chart in the center. Now let's just add another line. Let's go back to a trace. We're going to add our second line, trace 1, which comes below here, and it is also going to be S11. I can adjust its format, and I'm going to adjust it to log mag. And now this is S11. It's hard to see, but the zero's up here, and S11 is very low, which means that we're well matched. Just to illustrate that we are matched, I'm just going to disconnect our load. And this would be an open. So if we notice, all of a sudden, our signal has moved all the way over to the right here. And so that's exactly where we would expect for a Smith chart. It would stay in the center for impedance matched, and it would move all the way over here for a open. A short should move us all the way to the other side. So let's apply our short. We'll be looking for the one with the metallic pin center. And now we look at it, and now we're on this side of the Smith chart. Every time you calibrate, you should put on a 50 ohm, an open, and a short, and make sure it looks the same.